we look for, and that's how we are serving more than 25,000 customers across India. With the changes in mobility landscape, there are a lot of the vehicles are entering the market, and many, probably scores of them, are in the development stages. So what we are seeing, that traditionally the automotive industry is 1.5 century old, would mean lot of efforts have gone into design engineering for the whole vehicle, various systems, subsystems and components. And it's a very matured industry in terms of sustainability, in terms of performance, in terms of technology and various other components. But the electric mobility is a very new entrant in the market because of the compliances, the government rules and the mandates. Now the electric mobility industry doesn't have so much of time to run through traditional processes of design, engineering and innovation. So would also mean that we need a tool which can help us shorten the design engineering time, which is more optimum, very innovative, and this is a new field. The whole concept, the whole industry is new, would mean that we do it first time right, or we do it with limited iterations of engineering. So the OEMs, they do not have the leisure of the time or the freedom of the time to do traditional way. Would mean we look forward to a tool which connects various disciplines of the product, may it be two-wheeler, three-wheeler or four-wheeler electric mobility and the charging infrastructure. So that's how the industry is working. They are working very fast, of course, and we can see how quickly the products are being improved and launched in the market. Mostly they are driven by cost, compliances, the brand image, and various other factors. Now, essentially, if we see, there are five main parts for the complete these products, which is industrial design, which takes care of the aesthetics, the styling, the design engineering cycle and the processes, the design validation, and then this is done digital validation, and of course then goes to the prototype and the production engineering, plus the visualization. So there are five components of the product what we are looking at, mostly in the electric mobility space. And if we try to list down the process, it's industrial engineering, which takes care for the concept, and it's a very fast concept modeling. Then we've got product engineering, which is all mechanical, electrical, electronics, interiors, and other components. Product validation, where we have done the digital design, digital validation, and that's an iterative cycle, what probably couple of cycles we have to do to get to the optimum product. Production and manufacturing is the fourth piece. And our software, which is Autodesk Suite, we have got multiple bundles which addresses to all these four segments of the vehicle design. And if we break it down further to various pieces, again, it's industrial design, detail engineering for tubing, piping. Data interoperability would mean while you connect and generate a lot of data, they have to sync with each other, and back and forth communication has to be very seamless. They are mostly electromechanical components, visualization of each of these components, automation in terms of design engineering and in terms of manufacturing. And of course, the factory layout where we do the layout for the manufacturing setup and the marketing support, which is the piece of the visualization. So all these segments, all these pieces for vehicle engineering is being addressed in our software. And that's what we are going to present you in coming slides, bit more detail of this. And essentially, if we talk about the complete, the product, the vehicle level, the design could be innovative, it must be appealing, and that the validation of the design through the software would have been done. Now they are very, predominant in the market. Electromechanical, so all the systems integrated in terms of designing and testing, including the harness, and more essential because we do not have time to handle so many iterations. It has to be collaborative, would mean the changes in one system is immediately or online reflected to the other departments, and they can do collaborative. The same time, they can also take right decision in terms of design engineering changes and other factors, including integration with the manufacturing setup. So I have a video which talks about the product engineering work.
Your company relies on you to move your product's design through engineering and into manufacturing. You need a comprehensive set of engineering tools that will automate your everyday workflows, allowing you to focus on problem solving and adding value for your company. The Autodesk Product Design and Manufacturing Collection is a complete set of design, engineering and manufacturing tools with integrated data management. Create your design as a 3D digital model inside Autodesk Inventor and benefit in your downstream processes. Create configurable designs to efficiently respond to customer requests. Integrated simulation tools allow you to analyze and improve your product's performance earlier in the design process. Analyze tolerances and balance assembly fit versus machining cost. CAM toolpaths can be added in the same environment using the same data, updating automatically when the model is revised. Create PCBs in Fusion 360 and take advantage of Fusion's cloud connection for rendering, generative design, advanced simulation, and additive and subtractive CAM. Visualize and optimize your entire production line or work cell for maximum performance. And document your design with manufacturing drawings using the industry standard DWG format. Build on your experience with the tools you're familiar with and take your ideas to the next generation platform in the cloud. Decrease your time to market, reduce errors from manual processes, and increase the return from your investment in your Inventor model with the Autodesk Product Design and Manufacturing Collection. Your company relies on you to
made by Briggs Automotive Company. Engineering is challenged to design wire harnesses for several locations on the vehicle. This requires a control unit on the rear chassis. You can see we have some of the fuel injection and coil plug connectors to find the file that you need. In here we'll establish a link to the wires and whether they are connected or need to be assigned. Let's assign wires to a newly schematic ribbon. We'll begin applying the appropriate wire to each of the pins on the connectors. The placement is an intuitive process as the cursor will snap to the pin locations, making it easy to locate each wire. We'll do the same thing again for the purple wire between the fuel injector and the ECU. Let's go ahead and sync the schematic with the database and go back to the 3D model to finish needed. And finally, let's switch over to the existing nailboard drawing and make sure that it's up to date with the changes we have made. You can see some of the blocks are already in place for each connector. Each one of them is connected directly to the 3D model.
So we saw two videos. The first one was talking about the integrated engineering in terms of 2D, 3D manufacturing, and of course the shop floor design validation. And the second video is about harness design. How do we seamlessly connect between the schematics and the 3D routing for the wiring harness in an automotive environment. So that's the power of Autodesk bundle. So essentially what we are talking about is that, there could be multiple tools in the market which handle one part of your design engineering for the product. But here, and there are data losses, there are different expertise needed. You need to talk to various vendors. And of course, while, we offer you one platform wherein one source you could start from the scratch and start building your product, go parallel engineering, and then you conclude with all the outputs. So that's the strength of Autodesk bundle,
Made by
what
Briggs
we
Auto.
want to talk about here. So while all these components are being designed and engineered, it's very important because in terms of electric mobility, it's very important to have the lightweight design. So each component has to be lightweighted, which is probably the highest level of the engineering what we know about in the market. And enough of technology and tools have to be really explored to make these components very, very light, or as light, but also it has to be compliant, it has to be strong. So next couple of slides, we are going to talk about the new tools, how the world is using it to lightweight their designs. Not to talk about the the reliability, the fuel economy is very important for electric mobility, because we don't have the luxury of having a petrol pump every 5 kilometers, 10 kilometers, sometimes very, very short distance. So we are not really bothered about the fuel economy. But here the charging takes time, the infrastructure would take time to build up. There would be many in coming days, but also, so lightweighting is important. And if we reduce our vehicle weight by 10%, it adds 6 to 7% of the fuel economy. So that's the advantage what we are talking about. Essentially deep engineering, probably by tools, technologies, and of course the team. And you can lightweight it, you can make your product less expensive, less costly, and you increase the fuel economy. So that's the multiple benefit of a technology like lightweighting. So we are talking about shape generators, wherein our tool is based on AI, artificial intelligence. It's developed on machine learning, would mean that all three components what you see here, in fact they solve the same purpose. But if you see, their shapes are different, the material could be change in the material, but essentially then the cost benefit analysis could be done, and it lightweights your design, improves the performance, saves on the material cost, and of course the fuel economy and other aspects what we discussed just now. Like this case for the generative design, where this tool Fusion 360 which was used, it again adopts to the kind of manufacturing what you are using, the manufacturing infrastructure in your company. And you can try this design with multiple iterations. Like in this case, it was 10 types of material. You got enough options to choose what best suits you in terms of manufacturability, cost, light weighting, and other aspects of it. So multiple manufacturing methods. like additive or subtractive manufacturing, die casting, you are going for 3 and 5 axis milling, 2.5 axis milling, or other even sheet metal nesting. So these are the manufacturing practices, and it's very important to design your product vis-a-vis what's the manufacturing process you are going to adopt for your components. So manufacturing cost, if we see, and these are very critical shapes, you can see this is all designed by the component. You need to apply the loading conditions, you need to apply the constraints, and the outcome you can have multiple, probably in hundreds. Okay. And each of the components, when they are designed by the system, you will get relative comparison of what is the cost, which manufacturing technique, what is the material, with which material, how much of strength you could do. So that's the kind of AI what Autodesk provides. Now, like lightweighting of this motorbike, I would like to run a case study.
I've been a motorcyclist since 12 years old. In the late 90s, I got involved with a team building an electric Porsche for a national competition and really got intrigued and interested in electric power to power vehicles, and decided that a motorcycle was a really good application for electric. We started off with an R1 1000cc race chassis that we used to convert to build the first bike. The typical response that we had at the time was, why did you ruin a perfectly good 1000cc R1? The big milestone that we had set for a goal in 2006 after building the first bike was to be able to compete head-to-head with the best, fastest, internal combustion engine race bikes in a world-class competition and win. For a lot of people, they became believers after that. They believed that it was a viable technology. They were seeing the beginning of the future. Using Autodesk software that we have allows us to test and prove concepts in CAD, evolve them very quickly. We have CNC equipment where we can take those CAD designs and rapidly make working prototypes to test. We have 3D printing where we can also build components to test, build carbon fiber pieces, use them to build molds from. So it allows us to proof a theory or a concept very rapidly and then go into production with it. We believe that the electric drive technology is going to become the dominant form of powering transportation.
So we are looking at an electric bike which can run probably 100 miles with and all the specifications you can see. It's a full-fledged bike, and enough engineering is being done using our software, and that's how the global and local customers are benefiting through our technology. So we have another case. Any bike would have components which are very sensitive to load, which are going under a lot of vibration. They are safe, preserve components, which have to be better designed rather. And we could do a very fast iteration, like in this case, hundreds of design were produced by the system, given the inputs of the load, the constraints, and the material. So now you can see each of these design could be tested for the strength, resilience, cost, manufacturing. And in this case, this was an rear bracket for the two-wheeler. So imagine each of this could individually take months to design, but this probably would be done in days. And that's the power of technology, that's the power of tool, wherein, and this is the manufacturing process through additive manufacturing. You could do simulation for your CNC operations, and your the equipment is ready. As it is as fast as this, globally companies are adopting to this software. In this case, we are using Fusion 360, which is again part of the collection. And some other components, like look at this, component part by MJK. So that's an component part which is, manufactured by the company for OEMs. And then we can see the various design iterations, performed. So the top one you can see, which is done with 2.5 axis generative design. It's 2.5 kgs minus 23 kgs of weight reduction. Safety factor is 2.2, would mean this is designed and manufactured to take the load more than 2 times, and the cost is $130. So like this, each of the iterations, this is 3-axis generative design, 2.3 minus 23, cost is 145. Now here we have got 3 kgs, factor of safety 2.7, cost is 160. Likewise, so now imagine that you are giving multiple options to your customers, to your company, and to your management to do the right decision. And there is a software which is there to support you. Usually such designs would take a big team and lot of efforts to arrive at multiple options. This is an exhaust piece, very complicated. Now you can look at how the software is being used. Allow you to consolidate multiple components into one. Probably there were 2 or 3 components. Through the this system, it has been casted into one single component, which is much easier to handle. It is much stronger, lighter, and cheaper. So there is an example for the General Motors, the rear seat belt, which was earlier made from 8 components, but this could be redesigned into single component. So this is how here also it's an and all these components are lighter, they are stronger and cheaper. So these are the 3 objectives what every designer and every design manager is looking for. So that's the component what we are talking about, the rear seat belt bracket. Now you look at it, earlier traditionally it's about 8 components. Okay, 8 components we redesign into one component. So it's much easier to manage as a supply chain. It's very aerodynamically designed, and it's lighter, cheaper, one production process. And that's what probably the world of engineering is moving to. Advanced engineering, I'd like to run you a very aerospace case study. It will be interesting for you to see this.
We're trying to do something that's never been done before. Something that seemed impossible.
We are constantly trying to push our designs just a little bit further. I'm always saying, make it even better. Before I had Fusion 360, the question was, can I really make that? Now it's more like, what can't I make?
Now I have a simple way to solve really complicated problems.
Starting a project used to be so daunting. We'd spend days trying to make a prototype. I love how intuitive the software feels. It's like an extension of my brain.
Our team is really tight-knit, even though we have people all over the world. Fusion 360 keeps us connected.
I'm able to spend more time with the things that matter to me most because I can get my work done anytime, anywhere. It's an amazing feeling to hold something you've brought from idea to reality.
With Fusion 360, I don't have to compromise between cost or quality.
I'm an engineer.
I'm a machinist.
I'm a designer, and I use Fusion 360.
Fusion 360. One product, unlimited possibilities.
So while engineers, have become very competent, it's also important to have a tool which supports your, innovative ideas. So this is the tool, probably the complete bundle, and this essentially was made in Fusion 360. And imagine this is the lander, Mars lander was, designed and manufactured using this tool, which is so complicated, zero chances of failure, enough of, factor of safety. And that's the kind of, the deliverables or the designs which could be produced through this tool. And essentially many OEMs are going, today by adopting this tool. Also, this means that your existing design doesn't, existing data, whatever software you are working on, doesn't become obsolete. So this has any CAD integration. You could bring in data from multiple CAD, your existing data, and do the downstream engineering with this. So here what we are talking about, additive manufacturing, workflows which could be brought in here for advanced building, automatic packing, or metal powder bed fusion processes, direct energy deposition manufacturing processes, etc. And when we look at the cycle, let's see that we start from the CAD, we import the CAD or we build the CAD right from the concept, we optimize the design, we do a certain set of iteration in terms of validating the design, we build the supports, we do the packaging in terms of manufacturability study, and define the shape. Thereafter is the simulation, how the component manufacturing processes are simulated, tool path is optimized, and they are exported to the machine for manufacturing. So that's the typical process, how the design is getting integrated into the tool. So you're the modeling, 3D modeling step, the building rep, and the simulation. All three and the complete work process is integrated into one software. And so there are a lot of hassles of, data portability, losses could be avoided using such tools. And when we talk about, compression molding for the bodies, injection molding is our tool, which is, with which help we could lightweight the design, which is strong, stiff, highest quality, and of course the fiber reinforced plastics or the composites. So we are looking at the tool now. So plan, program, and produce, all three activities are handled, including manufacturing, your shop floor manufacturing, which is what we are going to touch. So it's a generative design tool, what we saw just now, design optimization through CAE and through the tool, of course. That's an automated process. Simulation analysis, additive and subtractive manufacturing, molding and tooling, CNC, metrology, composites and fabrications. Okay, and these are the multiple tools which is bundled in Autodesk, and the activities could be done is prototyping, metal jigs and fixtures, tooling, manufacturing, CMM, fabrication, and robotics. So now coming back to the factory, while uh, the product is being designed and the simulated manufacturing being done, what about the layouting of the manufacturing? So we also have an integrated tool which does the process concept, define, you could map the processes, manufacturing processes in the tool. You could do the rough layout and the space studies in our software. You could map detailed manufacturing, space, building equipment, supplier integration, material flow in, flow out, validate the design before the build up, okay, distribute the build up plan, and do a lot of studies around it, and of course the change management. So I would like to run a video to show you how does
The
it
need
look
to
like.
optimize production efficiency whilst minimizing downtime are becoming even more critical to remain competitive and control costs. Supplementing your traditional tools, such as 2D drawings and spreadsheets, with the tools inside the product design and manufacturing collection can help you to create a fully integrated factory model that can help you better respond to change while maintaining production efficiency. Look for efficiencies in your manufacturing process by modeling, studying, and optimizing your process using Autodesk Process Analysis. Analyze your processes to identify bottlenecks and optimize how many components can be produced in a specific period. In the planning phase, 2D layouts in AutoCAD are perfect for quickly conceptualizing multiple proposals. In addition, you can use your layout to analyze and optimize material flow, helping you to choose the most effective proposal. At any time, your 2D AutoCAD layout can be converted to a 3D model in Inventor with a single click. Factory design utility assets have bidirectional sync. You can configure your assets in AutoCAD or Inventor and your designs will remain in sync. Having a 3D model of your facility that is accurate to the current conditions helps your team to make informed decisions throughout the lifecycle process for plan, build, and operate. Your 3D model can be used to maximize use of space while preventing installation errors using clash detection. Analyzing the 3D digital model aggregated from 3D point cloud scans and your collaborators' CAD data helps you to avoid costly failures and reduces the need for a contingency budget. Accurately communicate your designs with 2D drawings created associatively from the 3D model. Plans, elevations, and sections are created by referencing the 3D model. Any changes to the model will automatically update in the drawings. The 3D model is also used to generate the equipment bill of materials, saving time and reducing the errors caused by a manual takeoff. During the planning phase of your project, incorporate scheduling information from Microsoft Project or Excel into your model and animate the project sequence to communicate your plan and look for problems during changes. Analyze your processes, strategically position and validate your equipment, plan for installation and operate the factory with the need.
So that's about the factory floor design. How do you virtually design, digitally design the factory floor? How do you map the manufacturing and assembly processes, different substations, do the time and motion analysis, okay? And some calculations like mean time between failure. This will help you reduce the iterations in doing the shop floor manufacturing processes, reduce lot of reworks, and digitally be more accurate whenever it comes into the production. So that's again the bundle. The software is provided along with our bundle, and essentially what we are looking at all four pieces of the complete cycle industry, which is industrial design, mechanical design and engineering, analysis and simulation, and manufacturing practices. So all four, they are different softwares for various activities. This is seamlessly integrated, connected with any CAD. The input could be from any CAD software, and you could do the downstream engineering from A to Z. Also, along with this, the Autodesk also has product data management, where a lot of the data generated through while doing these activities could be better managed in terms of workflow, in terms of approval, BOM management, data reuse, so that right version and revision controls are there, and that's also provided by us. So we are looking at what end-to-end software, which is easy to learn, easy to deploy, and actually very quickly gives result. So thank you for your time, everyone. This was a short presentation. Depending on your interest, we would be happy to support you further on your requirements. So we can have some Q&A sessions. So please post your questions. We can respond to this. So the question is, Autodesk is a software. Autodesk is a company which owns, which has developed the softwares, and that's what we are talking about, four pieces, which is industrial design and visualization is the activity where you've got multiple softwares. You've got mechanical design, you've got multiple softwares, and analysis and manufacturing. So Autodesk is the company which owns, which is the OEM, software OEM. Next question is, when we reduce the weight of the software, is it possible to strength of the vehicle remain durability? Yes, because we are not designing just for the strength. So strength, durability, again, the materials, you can change the materials, you can change the manufacturing type. How do you want to manufacture the component? So there are multiple factors which could be probably, and there's an AI based tool. You have to just put the inputs and software will do the job. So I'm just going to your chats and trying to get if there are some queries. So we'll be here for another 5 minutes. You've got some queries, please put it in the QA session or in the invitation. You would have my email ID. Please post it, write me a mail. We will help you out. So I believe no more questions. Please reach out to me one-to-one. Thank you very much, everybody, for joining this session.
We just
Yes,
got one
please.
question
Yes, please.
in the chat box. How can we design light parts?
how can we design light parts? So again, when you look at the component, it has to have a purpose. When it has a purpose would mean it's a strengthening member, it's a dynamic, which is a rotating part, or what kind of part it is. Obviously, the requirements. Okay, based on the requirements, you start thinking about the product, how it should look like, which ends it's going to connect, or what is the purpose. Okay, once you have designed the component, and then you do the analysis, which could be done in the software, which could be done through CAE methods. You could use Nestron solver to do the load testing, and after you have tested it for certain load, durability, and other factors, then you put these details in the software, which is Fusion 360 generative design. Okay, and software will start suggesting you how this could be made more lighter, because it may not be essentially always needed. Somewhere the weight could be extra, somewhere the material could be extra, somewhere it could be less. Software will identify the portion of the component which is weakest, so it will locally strengthen those areas, and it will reduce where it is over designed. Okay, so that's the very higher level explanation of how does the software works. So that's how, once it has reduced the material, it will become lighter, and then you could change the material, you could change the manufacturing way. Like here, some of the examples were in additive manufacturing, but also you could see how fascinating designs were made. If we make new design, after that, what is the process to available in the market? Any design is made, of course it goes for prototyping testing, and then and essentially everything has a purpose. Everything has a purpose, for what product, for which component, or which system you're working for. Any type of materials can be processed in CNC machining for getting desired product. Yes, manufacturing is all material handling. If it's plastics, you do mold design. So most other metallic materials can be machined. They are composites, doing even additive manufacturing or subtractive process. So yes, all the materials available, they can be manufactured. Is Autodesk and AutoCAD are same? So Autodesk is the name of the company. AutoCAD is one of the software from Autodesk, which is so widely available. But other than AutoCAD, there are probably another 50 softwares what Autodesk owns. Okay, some of them you are seeing here, some they represent other segments. Any type of material, yes, I think this is responded. It depends on what's the material. If it's plastics, if it's composites, there are different ways of manufacturing different materials. Any metallic components can be done through CNC. Sheet metal can be done through CNC, yes. See, there are a lot of questions around the materials. So meteorology is another subject probably. And if you see the similar component, you will have a good idea about those components were manufactured in which material and which manufacturing process. But some studies will have to be done to derive at what material to be used for producing or designing and producing what product. So essentially what also I'm trying to tell you is that once you have a component to be designed, you have to think about the material, the designing process, validating process, and redesigning to be more effective, which material, what manufacturing process, what cost. And everything is dependent, because if you take like additive manufacturing, so additive manufacturing is each component. So these are less number of components, but more strong, more durable, very light, the cost could be higher because these are not mass production. So we are not looking at sheet metal components which are mass produced. Sheet metal component could come into rupees. So some of the components what you see in your daily life, manufacturing costs are very less because they are designed once, they are validated once, and then put into production, serial production, and automated. If we design part light, will it be stable? Of course, you saw examples of how this Mars lander, it did do the job. This was lighter. It could be expensive. Okay, what is Fusion 360? So Fusion 360 is one software which is on the cloud, our cloud software, which has got again. So you could do most of the activities what we discussed today on the cloud. Would mean you have to have a very light workstation, that the designing whatever you do would be stored on the cloud. We all understand how the cloud works, right? And some softwares like generative design is also part of Fusion 360. So this is a software in our bundle. This could be bought separately, or this could be bought as part of the bundle, which is PDMC collections from Autodesk. Do we have trial version for designing light parts? Yes, you could go, if you just Google, you will get a link to download the software for 1 month of trial. You could do that. Only see that this is used for 1 month. Number two, you could not do any commercial project because these are all mapped through internet. Any other questions you can ask here or reach out to us. Just drop us a mail. And you need some requirement, again drop us a mail. Our team will revert back to you. We'll touch base with you to understand what you are doing, what you need, and propose the right solution. So probably no more questions. Everybody, thank you very much for your time, and I hope you had an interesting session. We keep I'm not able to send the PDF in question. Okay, probably just so Saurav, this for Saurav, please send me a mail. We'll respond to your queries. So, okay, gentlemen and ladies, thank you very much for your time. Hope this was an interesting session. Do reach out to us and let us know if whatever way we want to, you need our help. We keep on scheduling such sessions, and we look forward to further. Okay, thank you very much. Appreciate your time. This was an very interested audience. Thank you very much, and wish you all a nice day. Thank you. Bye bye.